Hi, Nick Collier here, and this is my shop. Come join me. We'll have some fun. Well, Nick Collier here, and I realized on the first video that I neglected to explain what I was building. So we're going to kind of do a little rehash here and come in and figure out what the hell we're doing. So basically what we're doing is building a gearbox for an earth drill. And the bit for the earth drill is, on this particular case, it's about 18 inches. And it drills a hole down into the earth so that they can build a foundation for houses in the Bay Area that are slipping down the hillside because of earthquakes. Now, earthquakes, not the big ones that happen every 100 years or so, but the little small ones, the little 0.3s and 0.5s that just kind of give a little bit of a shake, but everything kind of just settles down and settles down. And they built hundreds and hundreds and hundreds of homes on the side of the Oakland and Berkeley Hills that are now, this was hundreds of years ago, or not hundreds, but 100 years ago, that are now slipping. So they're, frantically going and drilling these holes in the earth and filling them full of rebar and then filling them full of concrete and landing the houses on the concrete piers. Sometimes they have to go down 50 feet in order to hit bedrock. So anyhow, what we're doing is we're reducing the speed of, and I'm going to bring this motor over to you, the hydraulic motor, and here it is here. Can you see that? Not so much. There it is right there. Now this is a one beefy ass motor. It travels 130 RPM, which is pretty slow, but it being hydraulic, it has a torque like you can't believe. Now I'm going to take that torque, put a gear on the end of this that matches the slewing bearing here, and the slewing bearing basically bolts to the housing, and this part of the bearing turns. Then we attach the hub, which we are in the middle of building at this moment. As far as the videos are concerned, we attach this hub to the bearing, the slewing bearing, which goes in these holes here, and then so the hub turns. The center shaft, or the center hole in the hub, has a square tubing or pretty thick wall tubing that goes through the center of it, that goes down into the earth. So basically the motor turns this turns the hub turns the shaft goes to the drill bit, and the drill bit digs down into the earth. Now, the other part of this process is we've got to build a housing for, and you can see the slewing bearing there. Can you see it? Yeah. And you can see the hub there. So we have to build a housing that goes around that. And of course, it's full of grease, so we have to build a couple of seals on the outside of that, and then this whole housing fits inside of a frame. Now, last December or so, I built 3 of these for a guy in Oakland, and but I built the entire frame and everything. This time I'm just building the gearbox because the guy already has the frame, and I guess his old gearbox gave out or something like that. I'm not sure. So this is what we got. This is the job. We're having fun. Okay, while we're letting the hub, which is going to go right inside of here, cool, we can we can work on this, and it looks like I got that thing pretty squared up. That's not too bad. But we got a lot to do, and it's hardened, so it's going to be a pain in the ass, but a doable one. I don't think we're going to make it. We're going to have to come in from this side. Okay, we're going to travel as slow as we can travel. Yeah, I got it on. Yeah, go ahead. Well, it's off, but you know, it could just be off because the cut was funny. But I think we're going to point out the interior hole, get that as close as possible, and then come back and cut the outside to fit the inside. Well, actually, now that I think of it, let's measure the inside hole and see how much room we actually have. We're at 5 inches, so we got a 1/2 inch of play there. That's not too bad. So let's see how far we're out here. Okay, there's our furthest point out. So we're about a 1/4 inch. I'm thinking a little bit of adjustment wouldn't hurt. That's pretty good. Now let's just make sure that that inside is doing okay. And all we got to do is just come up to it. Yeah, it looks great. Okay, let's check and make sure we're nice and snug, and we weren't. Pretty snug, pretty straight. Yeah, we're a 1/4 inch. Alright, what we got here is just a little bit of wobble, so I'm guessing one of these legs is not hanging in there. So we're going to mark our number, put a mark there. It's not very warm, so we're in good shape. We'll take this one off the other way. And we'll move this and take this one. And let's see what we've got as far as doesn't look like there's anything in the way. I'm not feeling anything. All right, well, maybe it just wasn't closed enough. Yeah, something's going on. Maybe it's a little warpy or something. Let's see what that looks like. Definitely off. Okay, we're taking the last 20 thousandths and hopefully that's going to clean us up. There's one little corner back there that might have a problem, but I might just leave it. Okay, well, here's what we've got. I put this on the super spacer, and I was going to set it up to space. We have 16 holes to do, and it was going to be 22.5 degrees each hole. And I was ready to go ahead and do that. So I set the whole thing up, and I got it centered, and I got everything. Oh, and by the way, I cut that inside ring, and didn't film that. So I got it set up, and I realized, wait a second, what am I doing? I don't need to fight 22.5 degrees. I can go up to the DRO and set it up that way. So, but I already had this thing set up, and I already was set up in center, and it's like, okay, it's a done deal. It's in good shape this way. So we're going to go up to the DRO and kind of walk through the process, because it's pretty cool. I had a couple of subscribers say, hey, how come you're not using the DRO? And I'm like, well, yeah, I guess that's true. Why am I not using the DRO? We'll take the plastic off so it's easier to see. Can you see it from there? Okay, we're going to spin around just a little bit. There we go. That's better. So, the set up for a hole pattern is that little dually bop right there, and basically what we do is get the mill centered on the piece itself, and then, oh, wait a second, we can't do that, can we? Well, we'll just take it back. Take it back to 0. Come on. There we go. Now we push the hole finder button, and it says something about checking whether it's going to be centered or not, and this is center for positive center, 0, 0, and that means we're dead center on the plate itself. And we'll swing down there so you can see that. Dead center. Okay. All right, so let's come back up. And so we're set. Press enter. And the diameter on this particular one wants to be 10 inches, 630 thousandths. So we're set there. The starting angle, I want it to be 0. And then the ending angle would be 360 degrees minus 22.5 degrees, which would be ending angle 337.5 degrees, right? And then we go, how many holes? 16. And we are ready to start. And it says number 1 hole, we're going to move the table this way by 5 inches, 315 thousandths. So let's move that. Okay, bring it down. To 0. Come down here and drill our first hole. Pretty much as simple as that. Alright, and the holes are gonna go to 5/8, but I think I'll walk around the whole thing first and drill the smaller hole, and that way we don't have to do a bunch of change outs. So we come up to our DRO again, and we press enter. Nope. Oh, we press the up button. Okay, we press the down button. Number 2 is 973 thousandths and 3 inches, or 9 inches 73 thousandths and 3 inches 75/8. Okay, so then we just come here and we bring everything back to 0. So it would be so we go all the way across? That seems silly. Alright. It says go all the way across. 4, 0. Well, something happened. As usual. I got some calculation off. Okay, let's see what number 3 has to offer. All right, there's number 1. All right, so let's just get out of here and take this back to 0. Okay, 0. We press our X and Y. Yes. Positive. Center point. Diameter 10.63. Yes. Starting angle 0. Ending angle decimal point 337.5. Okay, 337.5. Enter. Nope, back up. Well, we just have to go on. Number of holes 16. So number 1. Close this out. Turn this back on. All the way back to 0. 10, 6, 300. Right? Starting angle, ending angle. 337.5. 337.5 equals. I think that's it. 16 holes, number 1 hole, and we're still on the number 1 hole. Okay. Zero. Okay. So we drill 0. Yep. Now press the button, number 2 hole. 440 thousandths, one direction. Well, 2 inches. Oh, the other way. There we go. And then bring this over to 0. And there's hole number 2. And I'm thinking that's it. But you know, I'm not totally positive, so what we're going to do is we're going to spot it first. Okay, there's hole number 2. Back up to hole number 3. 15 or 1 inch. So almost 2 inches. Zero. Shit, we're not gonna make it. Maybe. Come on. We're at hole number 3. Come back up to hole number 4. Oh man, come on. We're still clear. All right. And we'll do the rest of them off camera, and we'll be back with you soon. Okay, we're done. One what probably took you about 30 seconds to watch took me about 2.5 hours. So the wonders of fast forward. We're going to go over to the lathe next, and we'll be back.